Hi students, നമ്മൾ ഇന്ന് ചെയിൻ റൂൾ ആണ് പഠിക്കാൻ പോകുന്നത്. ചെയിൻ റൂൾ ഫോർ ഡിഫറൻസിയേഷൻ. ചെയിൻ റൂൾ നിങ്ങൾക്കറിയാം. If y is a function of x and z is a function of y, then z is a function of x and dz by dx is equal to dz by dy into dy by dx. അതാണ് ചെയിൻ റൂൾ. അത് നമ്മുടെ functions of several variables ന്റെ കേസിൽ എങ്ങനെയാണ് അത് വർക്ക് ചെയ്യുക, പിന്നെ അതിന്റെ പ്രൂഫ് തുടങ്ങിയിട്ടുള്ള കാര്യങ്ങളാണ് ഇന്ന് ഡിസ്കസ് ചെയ്യാൻ പോണത്. സോ ഫോർമൽ സ്റ്റേറ്റ്മെന്റ് ഇതാണ്. Suppose E is an open subset of Rn is an open subset of Rn. F is a mapping of E into Rm, and suppose that U is an open subset of the codomain Rm, which contains f of E. That means the image of E under F. Then we can talk about the composite function. For the composite function G composite F to make sense, we should have image of F contained in the domain of G. So for that I am assuming U is an open subset of Rm containing the image of E under F. Now assume that f is differentiable at the point x0 in E, and G is differentiable at the point f of x0 in f of E. Then the composite function f is equal to vector. This is a vector valued function. So that's why I am putting an line above f, g and your capital F also. Then vector f is equal to vector g composite vector f from E to Rk is differentiable at the point x0, and the derivative of capital F, f dash at the point x0 is equal to the derivative of g at the point f of x0, g dash at f of x0 composite with the derivative of f at the point x0. So this is the chain rule. We shall prove this. Before that, let us go to a diagrammatic representation. So f is a mapping of E into Rm, where E is an open subset of Rn. And look at the image f of E. It is contained in the open subset U of Rm, and on that U your function G is defined. So G composite F makes sense. Call it capital F. This is at the level of the given functions small f, small g and capital F. So this diagram, I think it is clear to you. Now what does the chain rule say? Chain rule says f dash at x0 is equal to g dash at f of x0 composite with f dash at small x0. So this diagram is at the level of derivatives. F was a mapping from E to Rm, where E is an open subset of Rn. Therefore, as we learned, f dash at x0 is a linear transformation from Rn to Rm. Similarly, G is a mapping of U into Rk, where U was an open subset of Rm. So G dash of Y is a linear transformation from Rm to Rk for every Y in U. But f dash of x naught, it is in U because f dash of x naught, f of x naught, it is in U because f of x naught is in f of e and f of e is contained in U. So to compute the derivative of this map, capital F dash is this map, capital F dash is this map, it is equal to this map composed with this map. So this is what the chain rule says. This is at the level of derivatives. We shall prove this proof of chain rule. So x naught was a point of V at which f is differentiable. So put y naught is equal to f of x naught. A is the linear transformation f dash of x naught. This is from where to where? It is from Rn to Rm. And B is the linear transformation G dash of y naught. This is from where to where? This is from Rm to Rk. Now you define U of h is equal to f of x naught plus h minus f of x naught minus ah, and V of k equal to g of y naught plus k minus g of y naught minus bk. So what are these h and k? H in Rn, k in Rm, and if norm of h and norm of k are small enough, then x naught plus h will belong to E, y naught plus k will belong to U, and f of x naught plus h and g of y naught plus k both are defined. Okay. Now you define epsilon of h equal to norm of UH divided by norm of h. Here norm of h is there, so two lines. Similarly, you define eta of k is equal to norm of V of k divided by norm of k. Then epsilon of h tends to 0 as h tends to 0, and eta of k tends to 0 as k tends to 0. This is simply by the definition of derivative. What is derivative? Remember, since h is differentiable at x naught, you have f of x naught of h minus f of x naught minus ah, norm of this, divided by norm of h. Limit of that is equal to 0 as h tends to 0. That is precisely saying norm of u of h divided by norm of h. Limit of that equal to 0. Precisely saying epsilon of h tends to 0 as h tends to 0. Similarly, you have since g is differentiable at y naught equal to f of x naught, eta of k tends to 0 as k tends to 0. Hope you understood so far. Proof continues. Now onwards, my k is not arbitrary, as I said earlier. My k will depend upon h. So given h, put k is equal to f of x naught of h, x naught plus h minus f of x naught. This is my k. Then norm of k. Norm of k is norm of f of x naught plus h minus f of x naught, which is precisely ah plus uh. You get the previous slide? F of x naught of h minus f of x naught is precisely uh plus ah. So norm of k is norm of ah plus uh, which is less than or equal to norm of a of h plus norm of u of h. But norm of a of h is less than or equal to norm into norm h plus norm of u of h is, as we observed, it is epsilon of h into norm of h. So norm of h you can take out and write less than or equal to norm a plus epsilon of h into norm of h. So mark it as 2. Hope you understood this much. Now we will look at capital F of x naught plus h minus f of x naught minus dAh. Look at this. What is capital F? It is G composite F. So I will write here the LHS, f of x naught plus h minus f of x naught. So it is G composite F at the point x naught plus h minus G composite F at the point x naught. So this is equal to G of, what is f of x naught plus h? It is y. What is f of x naught plus h? Look at the previous slide. F of x naught plus h is u of h plus f of x naught plus ah. U of h plus f of x naught plus ah. It is G of, excuse me, G of f of x naught plus h minus G of f of x naught minus dAh is there. Minus dAh is there in the left side. Minus dAh is there in the left side. And okay, remember what is your k? K is f of x naught plus h minus f of x naught. So what is f of x naught plus h? It is f of x naught plus k. but f of x naught is y naught. So f of x naught plus h is y naught plus k. Hope you understood. So it is g of f of x naught plus h is g of y naught plus k. Y naught plus k minus g of, what is f of x naught? It is y naught minus dh. Minus dh, which is equal to g of y naught plus k, because f of x naught is y naught, minus g of y naught minus dh, which is equal to, now you take d out. So b of k minus ah plus vk equal to v of uh plus v of k. Hope you understood. I will write f of x naught plus h minus f of x naught, f of x naught plus h minus f of x naught minus dah, dA vector h, everywhere vector is there, equal to g of small f of x naught plus h minus g of f of x naught minus dAh equal to g of, that is f of x naught plus h, it is y naught plus k by definition of k, y naught plus k minus g of, what is f of x naught? It is y naught g of y naught minus dAh equal to let us go to the previous slide. What is g of y naught plus k? It is g of y naught plus bk plus vk, g of y naught plus bk plus vk. So it is G of y naught plus k is G of y naught, G of y naught plus bk plus vk, vk minus G of y naught. This G of y naught, G of y naught minus dh. This much is there. This G of y naught cancels with this G of y naught, and from this bk and from this bah you take b out, so it is b into k minus ah, k minus ah plus your v of k. Hope you understood. That is this step. That is this step. F of x naught plus h minus f of x naught minus bah is b of u buh plus vk. The proof continues. Now you take norm of f of x naught plus h minus f of x naught minus bah. So what you will get? It is less than or equal to norm of b of uh plus norm of v of k. Right? Don't divide by this norm h right now. Just take the numerator only. Don't take the denominator. So what I will get? Look at the previous slide. Here you will get norm of f of x naught plus h minus f of x naught minus bah norm. So that is less than or equal to norm of b of k minus ah plus norm of vk. So this is what we are going to get. But k minus ah, what is k minus a? What is k minus ah? It is precisely uh. So norm of b of uh plus norm of v of k. But norm of b of uh is less than or equal to norm b into norm of uh. Norm b into norm of uh plus norm of v of k. But norm b into norm of uh is again less than or equal to, substitute for norm of u of h, you will get less than or equal to norm b into norm of epsilon of h into norm of h. Plus eta k into norm of v of k is less than or equal to eta k into norm of k. So apply that, you will get norm of v of k less than or equal to what is norm of eta of k? So keep as it is, norm of eta of k, keep as it is. Now substitute for norm of k. What is norm of k? It is precisely using to norm a plus epsilon h times norm of h. So norm of h is there here. Now divide by this norm of h, both sides. So this goes, this comes. When you divide by norm of h, this goes. and you have this thing. Hope you understood. Now take limit as h tends to 0. Then as we observed, epsilon of h tends to 0. Also, what is 2? 2 is norm of k is less than or equal to norm a plus epsilon of h into norm of h. Therefore, norm k also tends to 0 as epsilon tends to 0. Once norm k tends to 0, you have eta k tends to 0. So this quantity tends to 0 as h tends to 0. Epsilon of h also tends to 0 as h tends to 0. So the total right side tends to 0 as h tends to 0. That means left side also tends to 0. This is precisely saying capital F is differentiable at the point x naught with capital F dash at x naught is equal to BA. But what is B? It is G dash at the point f of x naught. Composite with what is A? The linear transformation f dash at x naught. And this is what you want to prove. Go through the proof. Read the text once again. I have a lot of limitations because I am using PowerPoint. So go through the proof once again and convince yourself. Thank you.